Okay, so this is lesson 1-1, one variable equations, and we're just gonna kind of fly through this here. All right, and so first of all, learning targets, we're gonna create an equation in one variable from a real world context, and we're gonna solve an equation in one variable. Let's see here. So here's the situation. So a new water park called Sapphire Island is about to have its official grand opening. The staff is putting up signs to provide information to customers before the park opens to the general public. As you read the following scenario, mark the text to identify key information and parts of sentences that may help you make meaning from the text. Okay, so the Penguin is one of the park's tube rides, and it has two water slides that share a single line of riders. The table represents information about the number of riders and tubes that can use each slide. All right, so here we've got this table, Penguin water slides, and so we've got, remember, one line here, okay, one line, and you can go to two different slides. So slide number one is the tube size has two riders. All right, so every time you take a slide, there's two riders on there. And how long, what is the tube release time? Well, or in other words, how long does it take them to go down the slide? And then for the next people to start the slide, it's 0.75 minutes, which is 45 seconds, but I don't think we'll need to, we won't need that information, but it's 0.75 minutes. And the second slide has four riders every single time they slide down. And that one takes 1.25 minutes before the next group of four riders can go down. Okay, so one line, and we got two slides. Each slide, one slide can hold two riders, and the other one is four riders. All right, so Jabir places a sign at the waiting line for the Penguin. All right, so when a rider reaches the sign, will be approximately 100 people. I'm sorry, there will be approximately 100 people in front of him, or in the or her waiting for either slide. Okay, so there's a big line. Once you hit the sign, there will be approximately 100 people in front of you. All right, the sign states from this point, your wait time is approximately blank minutes. Okay, Jabir needs to determine the number of minutes to write on the sign. In this case, obviously, we're not working with a partner. Okay, so we're going to let the variable r represent the number of riders taking slide 1, the total number of riders who are going to take slide 1. Okay, so we're going to write an algebraic expression for the number of tubes this many riders will need, assuming each tube is full, meaning slide 1, two riders can go down every single time. Okay, the tube every single time. Okay, so an example might be like if there were 50 people, if R was 50 total riders going down slide 1, then how many tubes would they need? How many times would they slide down? Well, if there's 50 people and they're going two at a time, then that's 25 slides, or 25 tubes in this case. They're using the word tubes here. All right, so in other words, if we have R people, how many tubes are we going to need? How many times are we going to slide down? Well, that would be R divided by 2. Okay. All right, so let's see here. So next we're going to write an expression for the time in minutes it will take R riders to go down slide 1. Okay, so we already determined, well, if we have, again, I'm going to use the example 50. If there were 50 people and they can go two at a time, then that would be 25 tubes. And how much time does it take for each slide? Well, we have that information right here, which is 0.75 minutes. In that case, it would be 50 divided by 2, and then which would be 25, and then times 0.75 minutes. That's how long. All right, but we're going to make this arbitrary, and we're calling it R. So in this case, it's like we did right here. So it's R divided by 2. That's how many tubes we're going to need, how many times we're going to slide down, times how much time it takes in minutes, which would be 0.75 minutes. Like so. Okay, or R over 2 times 0.75. I don't know if you really have to put the minutes there, but it's good to label. All right, so assuming that our riders take slide 1, so far we're all just, we got a bunch of people here, and R is representing how many of those people are going to go on slide 1. All right, so our riders take slide 1, and that there are 100 riders in all. Write an expression for the number of riders who will take slide 2. Well, if there's 100 riders total and R are taking slide 1, then 100 minus R must be taking slide 2, right? Again, if I'll use my example, if 50 are taking slide 1, then how many are left out of 100 to take slide 2? Well, 100 minus 50 is 50. All right. So let's keep going here. So we're going to use the expression we wrote in item 3, which was, that was just 100 minus R. Oops. 100 minus R. And we're going to write an expression for the number of tubes the riders taking slide 2 will need, assuming that each tube is full. So let's remember here, slide 2 can handle 4 riders at a time. And we know that slide 1, the number of riders is R, right? And we said that for slide 2, the number of riders would be 100 minus R. Okay? And for slide 1, we said, well, if there's 50 riders, then how many tubes would you need? Well, 50 divided by 2, because 2 people are going every time, that would be 25. All right, but if slide 2 is 100 minus R riders, and it takes 4 riders at a time, how many riders do we need? Well, it would be however many divided by 4, right? So 100 minus R divided by 4. So let's go ahead and put that in down here, because that's what this question is asking. Okay, how many tubes do you need? Let's see here. Write an expression for the number of tubes the riders taking slide 2 will need. Well, that's 100 minus R divided by 4. All right, and next up, I'm assuming they're going to need the time for slide 2, which looks like what they're asking. So write an expression for the time in minutes needed for the riders taking slide 2 to go down the slide. Well, okay, we know how many different tubes we need, right? How many times they're sliding down, which is 100 minus R divided by 4. I'll put that in parentheses. Because we're going to multiply it now by how long it takes for each tube. And if we scroll up, then we see here that it takes 1.25 minutes, or a minute and 15 seconds, in order for each one of these to go down the slide. So we'll say times 1.25 minutes. And that's how long it's going to take. Okay. All right, so let's keep going here. Since Jabir wants to know how long it takes for 100 riders to complete the ride when both slides are in use, the total time for the riders taking slide 1 should equal the total time for riders taking slide 2. So write an equation that sets your expression from item 2, the time for slide 1 riders, equal to your expression from item 5, which is the time for slide 2 riders. So the first expression was R divided by 2, and that was times 0.75 minutes. And we're going to set that equal to the time for slide 2. So this one here is slide 1. And this one over here is slide 2. And slide 2 was 100 minus R divided by 4. That's how many tubes they need. And it was 1.25 seconds. I'm sorry, 1.25 minutes for how every single time that they go down. All right, so here's our equation. Notice we have one variable, one equation, one variable, one variable. Slightly complicated, but still, nevertheless, one equation, one variable. And so number 7 is going to ask us then solve that equation, okay? And remember, we're solving for R. And let's just remember that R represents the number of people in line that are going to take slide 1. That's what it represents. So we're going to go ahead and solve for that. So let's go ahead and write down our original. And so that would be original equation here, which is R over 2 times 0.75. And by the way, there's a lot of different ways to solve this. I'm going to do it one way, I guess. 100 minus R over 4 and times 1.25. Okay. Like, for example, one way to solve this might be to convert this 0.75. Instead of writing 0.75, you can write 3/4, and you could multiply that in there. Instead of writing this 1.25, you could write 5/4, and multiply it out. I'm just going to kind of leave it as is. Again, there are a lot of different ways to do this. I'm just going to start combining. That's what I'm going to do. I'm literally going to multiply 0.75 times r over 2. And when I multiply this, it multiplies times the top, 0.75 times r. So this becomes 0.75r, 0.75r like that, over 2. All right, just multiplies the top. And I'm going to multiply the 1.25 to the top. I'm going to distribute this to the 100 and to the 100 minus r. So let's see here. 1.25 times 100 would be 125 minus 1.25 times r, all over 4. Okay, so there's there's a few different ways to take care of these denominators. I want to get rid of these denominators right now. You can multiply both sides by 4, and that would actually remove those denominators. But a lot of you probably, I'm assuming, like to do the cross multiplication thing where you're multiplying these two and then you're going to multiply these two. So we're going to go ahead and do that since that's probably what you're used to. So I'm going to say 4 times 0.75r, and let's see here, that would be 3r on this side, is equal to, and I'm going to say 2 times this quantity, so I need to distribute 2 to this binomial right here, 125 minus 1.25r. So let's see here, 2 times 125 would be 250, minus 2 times 1.25 would be 2.5r. All right, we're getting there. And so let's go ahead and add 2.5r to this to both sides. So that way we would end up getting 5.5r, 3r plus 2.5r, is equal to 250. And then we need to go ahead and divide the 250 by 5.5, and you should end up getting, let me just calculate that real quick in my calculator. So you end up getting 45.45 repeating, and so I'm just going to round that, since we are talking about people, I'm going to say 45.5. And again, later I'm sure they're going to have me round that per person, because you can't have half a person, can you? So I think that, I don't know if that's the next one or not. But anyway, so we get r is equal to 45.5. And I just want to reiterate, what are we solving here? What is r representing? R represents the number of people in line that are going to take slide 1. Okay? So let's go ahead and scroll down. All right, so number 8, making sense of the problems. All right, consider the meaning of the solution, right? Which is kind of what I just talked about. Explain why you should or should not round the r to the nearest whole number. Yeah, we should, right? So I'm just going to circle that. I'm just going to write, because you can't have half a person, can you? Or I guess you could, but they wouldn't be having a lot of fun, would they? All right. So anyway, so how many people out of the 100 riders will take slide 1? Well, again, it's not going to be 45.5. Let's round that, and we're going to round it to 46. All right. So let's see here. Use the expression you wrote in item 2 to determine how long it will take the number of riders from item 8b to go through slide 1. So evaluate the expression for the appropriate value of r. So remember, slide 1, there's going to be 46 riders. And if you recall, we said that the expression for how long it would take, it was r over 2. You could put parentheses if you want there, times 0.75 minutes. All right, which means that if there's r is 46, so that'd be 46 divided by 2 times 0.75 minutes, which is equal to I'm not sure. Let's calculate that real quick. So 46 divided by 2 is 23 times 0.75 or 3/4, which would be 17.25 minutes. Let's see here, 17.25 minutes. A little sloppy there. Evaluate the expression for the appropriate value of R. Let's see, did I do the wrong thing here? How many minutes will it take riders to go through slide 1, round to the nearest minute? So actually, I pretty much just solved that one on accident. I got ahead of myself here. So this goes down here. So we'll say we're not going to round, or I'm sorry, we are rounding to the nearest minute. So that would be 17. That is a terrible 7. 17 minutes. Okay. Let's see here. Let's keep going. So the rest of the 100 riders will go through slide 2, and we already said 46 are going through slide 1. But anyway, the rest of the riders will go through slide 2 in about the same amount of time. So your answer to item 9B gives you an estimate of the number of minutes it will take all 100 riders to go down Penguin slides. Let's see here. Recall that when a rider reaches the sign, there will be approximately 100 people waiting in front of him or her. What should Jabir writes to complete the statement on the sign? Okay, so if it's going to take 17 minutes for slide 1 and 17 minutes for slide 2, but remember they can go down those at the same time, right? They're two different slides. Then if they're going down at the same time, then it should take approximately 17 minutes. Okay, and I think this is the last one here. Yes, it is. So describe how you could check your answer to item 10 and or check that your answer in item 10 is reasonable. Well, let's see here. So 10, we got 17 minutes. I guess we could plug it into our equation. That would be probably the best way to go there. So plug into equation, from, where was that? Plug into our equation from number 6, right? We came up with these this equation right here, so we could go ahead and plug that in. Okay, and make sure it works. Okay, plug into equation from number 6. Okay, and that's how you would test. All right, there's probably other ways to do it, but that's the one I can think of right now. Okay, and that takes care of lesson 1-1 in Unit 1 for Algebra 2 Honors.